Right, time value of money. Let me remind you what this topic is all about. This topic focuses on the idea that £1 today is worth more than £1 received tomorrow and significantly more than £1 received in 5 or 10 years' time. In other words, the time value of money is the idea which tells you that any future cash flows must be discounted because we prefer to receive the same payments today rather than tomorrow. It's more valuable for us. Due to risk, for example, if we are promised that someone pays us £1,000 10 years later, there is a risk involved that this will never happen. Moreover, there is certain inflation which will take place during this period, and we would prefer to receive this payment now because its purchasing power will be higher if we receive it now rather than later. Moreover, most importantly, we can invest this amount. We can earn interest during this period, and at the end of these 10 years, we will have significantly higher sum compared to £1,000. This is all what time value of money means. And in this lecture, we've developed various formulas which will allow us to calculate future and present value of various cash flows, to bring them to a single denominator so that we are able to compare them. Because cash flows received in different time periods cannot be directly compared. It's like adding up apples and oranges. They have different value because they're received in different periods. In order to compare or add them up, calculate the combined value of a project, we need to bring all cash flows into single terms, into present terms normally. Or the other way around. Sometimes we invest a certain sum for a certain period of time and we want to calculate what the future value will be, how much capital we will have at the end of the investment period, right? So this is what we are doing in the first particular exercise. First exercise asks you to calculate the future value of a present sum. We deposit a certain amount of money, £10. This particular account or particular project which pays 5% interest compounded annually, how much will we have after a certain period? To calculate this, we use the future value formula, which is simply the present value times 1 plus our interest rate raised to power n, where n is the number of periods for which we invest. For example, we have £10 today, so this is year 0. In today's terms, it's worth £10. In year 1, it will be worth £10 plus 5% out of this £10. In year 2, it will be worth this amount plus 5 more percent, and so on. And if we simplify this formula, we will get the present value, our initial invested sum, £10, multiplied by our compound factor. This is what we call the compounding factor, or future value factor. Why it's important? Because we might be able to find the value of this factor in a table. You don't necessarily need to calculate this each time because there are pre-calculated numbers readily available for you, and I'll show you the table how to use them. So what you need to do in reality, you just take the invested capital, the present value, which you're investing now, and multiply it by this compound factor. Let's apply the formula first. So in 10 years, you will have your £10 invested. Let me just make it bigger. You apply your compound factor, 1 plus 5% return raised to power 10. The value of the compound factor will be equal to this amount, which means that in 10 years you will have £16.29. In 50 years you do the same thing, but you raise your compound factor to power 50, to power 100 for 100 years, and you will get different numbers. Apparently, the longer the time period, the higher the value of your capital will be. You will compound this, you will earn return on your capital for a longer period of time. Let me show you how to find the value of this factor in a table. So we have 10 years. This is the information which we need, 10 years, and the return is 5%. Let me show you the tables. They're available on Moodle. There are 4 tables here. Future value table, present value table, the value of annuities, future and present value. 4 different tables. They will give obviously different results, so make sure that you use correct table. So we are trying to calculate the future value of £1. We are earning 5% return, so we are using this specific column, a 5% return, and we are applying this for 10 years. In other words, we will need to use this specific line and this specific column. This column, I cannot really highlight it here in this program, so it's this column. And the intersection will show us the exact number which we need. So it will be this specific number, this factor, 162,889. And this is exactly what we have here, 162,889. So here it was rounded up slightly. So you can find the value of these factors, the term in brackets raised to a certain power, using the tables. And we will do this in some other exercises. So this is how you can simplify your calculations. Because it's easier just to multiply your initial capital by this number. It's much quicker. We literally take 2 seconds to do this. Find a number, multiply it, and that's it. You've got your result. If you need to apply this for a different interest return or a different time period, you just use a different intersection of column and the row. That's it. Any questions based on this? No? Okay. Second exercise, very similar exercise. John deposited £1,000 in a saving account, earning 6% interest rate. How much will he have at the end of 3 years? So we have £1,000 now, 6% returned each year. This year, and this year. In other words, we compound interest return 3 times. So in order to do a calculation, these are our inputs. Interest rate is 6%, number of periods is 3, present value is 1,000. Plug all of these numbers into our formula, and again we will get the result, 1,199. Or similarly, we can find this compound factor in a table. So let's have a look. Number of periods is 3, interest rate is 6. Let's go back. Interest rate is 6. In other words, we are looking at this particular column and 3 years, so we will be using this particular line, right? So our compound factor is 1.19102. 1.19102. Again, here we've just rounded up slightly. You can use more precise number. Multiply it by 1,000 and you will be able to calculate the final value of the capital at the end of the investment period. Any questions based on this? This is how we calculate future value. In the lecture, I also explain you the difference between simple interest and compound interest. The difference is that simple interest implies that you are only earning return on the original invested capital, while compound interest earns interest on interest as well. In majority of cases, it will be compound interest. This is how majority of investments work. Your interest is accumulated every single year. It's compounded annually. Simple interest is only relevant for special cases. So unless stated otherwise, assume that it's compounded, right? In exams and so on. In majority of cases, it's very rare situation when you earn or pay interest on the original borrowed sum only. Normally, it's compounded. Okay, let's skip 3 for now. I want to do exercise 6. If we'll have time, we'll come back to this. Here, this exercise focuses on a slightly different thing. If we compound annually or quarterly. If we compound it annually, we apply our normal formula, 4% during 10 periods, and we will get 3,700. This is the difference between annual and quarterly compounded. What will be the result if your interest is compounded quarterly or monthly? We apply the same formula, but we adjust the number of periods. In other words, here we have 10 years at 4%, but here we will have 40 quarters, 4 quarters per each year, times 10 years, but at a different interest rate, because we will only have 1% per quarter. 4% annually is the same as 1% per quarter on a quarterly basis. So if you ask to apply the compounding with a different frequency, monthly or quarterly, you simply adjust the number of periods. So your quarterly return will be 1%. We have 40 quarters in 10 years. That is why you apply different number of periods and the different interest rate. And because you have more episodes of compounding, you've compounded more times, your result will be slightly higher. You can see that the actual end balance is going to be £3,722 rather than 3,700. You are earning slightly more if you're offered to compound on a quarterly basis. If you're offered to compound on a daily basis, you would do the same thing. You would take 2,500. You apply a different interest rate, so 4% per year is the same as 4% divided by 365 per day, right? This is what you would get per day. How many days will you have? You will have 10 years at 365 per each day. right? So if you are asked to compound with a different frequency rather than annual, you simply adjust the interest rate, which you earn per period, and the number of periods. Okay? Yeah. And now we do the next exercise is exercise 5 on discounting. What is the present value? How much do we need to deposit today in order to reach this sum? For example, you are saving to buy a car, or you are saving for a deposit to buy a house, or you plan to pay your tuition fees at master's level, for example, and you plan to do this in certain number of years. So you are saving for retirement, or you want to pay for your children's education. So this is very relevant. You have a certain amount of years to save, right? How much do you need to invest now in order to reach this financial goal? This is what discounting helps you to do. We are trying to calculate the present value of a future cash flow, and in order to do this, we apply this specific formula. This is discounting formula. Very, very important formula. You need to become very comfortable with this. It allows you to convert future value into today's terms. This is how you do it. For example, we'll receive a payment in the future, this payment in 8 years. So this is where we are now, year 0. In 8 years, year 8, we will have £100,000. Could be a pension payment as well. Yeah. By your retirement age, you will reach a certain amount in your bank account, in your savings account. So 8 times 3, 4, and so on, 8 times, and you are earning 10% interest. The question is, how much do you need to invest now in order to get this promised payment? What amount of money is the equivalent of 100,000 in 8 years? In other words, you need to calculate the present value of this future payment. And as I said, you apply the discounting formula, which is just this one, right? So this is what we are doing here. This is our future value, our capital, future value. We need to divide this by our discount factor, so 1 plus 10%, right? And we raise this to power 8, and this is what we have here. And as a result, we will get a number equal to 46,000. This is what we've got, 46,651. This is the actual number. Please pay attention. The present value, this is the present value, is less than the future value. But it should be like this, because if you invest this smaller sum now, at 10% return for 8 years, your capital will grow. And in 8 years, it will reach exactly £100,000. So it should be smaller. If your result is greater, it means that you've made a mistake. The future value should be greater than present value. Present value is lower than future value. Or you can actually find this discount factor from the table. There are tables as well, from the present and future value tables. Have a look. If we go back to our tables, so these are future value, just find the correct table. This is the present value table. This is what we need. We are trying to work out the present value, and this table will contain data on the whole fraction straight away. So what we'll need to do, we'll need to take the capital, the actual future value, and multiply it by this number, because it's divided already. It's divided by the discounting factor straight away. So here we earn return at 10%. This is our return. And we also invest for 8 years, so we select this row, which means that our discount factor is going to be this one, 0.46,651. 0.46,651. This is where we found it, right? So please pay attention. If you find the discount factor in the table, you don't divide it, you multiply it straight away, because it gives you this particular value. Have a look. The original formula, present value, is future value divided by 1 plus interest rate raised to power n, which actually means that we take future value and multiply it by 1 divided by this specific denominator. And this value can be found in a table, which means that we can only then multiply future value by this specific number. Okay? Let's do exercise 7, because I think these are quite interesting. And they are very relevant to your personal life as well. You are offered a free credit on a new £10,000 car. And you have 2 payment options. You can pay £1,000 upfront, plus £3,000 per year for the next 3 years, right? So this is the first offer in one company. They offer you this specific like payment plan, £1,000 deposit plus 3 years payments. Interest free, which is quite nice, right, for 3 years. We call this particular payment plan an annuity. Annuity is a situation when a certain payment is received or paid at set intervals, and you pay or receive equivalent amount every time. So equal cash flows for a certain period of time. So here we have a set payment, £3,000 for 3 years. The same cash flow each year for a certain number of years. This is what we call annuity. You can pay annuities or you can receive annuities. For example, if you have a rental property and you receive £3,000 rental income each year, this will be an annuity which you receive rather than pay. Yep. And for example, you have signed the tenancy agreement with your tenant for 10 years. So you can expect to receive it for a certain period of time. This is the expected cash flow, annuity. So this is the first offer. Another offer by another company next door, no free credit, but they can give you a discount, £1,000. So you pay, in reality, the next offer, £9,000 upfront. What is better? What should you choose? Quite interesting situation. Is it better to get an interest-free credit and pay the full £10,000 or get £9,000 straight away? The thing is, your decision will depend on the interest which you can earn elsewhere. Because if you can delay payments, right, get a credit and earn some return on this saved money, which you pay later, you might be better off. When you pay upfront, even if it's cheaper, you might actually be worse off because you could have invested this money and generated higher return, right? Maybe during these 3 years, you could get a better return rather than £1,000 offered to you. So we'll need to compare these offers. And to do this, we'll need to compare present values of both offers. So how much is each payment plan is worth in today's terms? What is the equivalent amount in present value terms? With the second offer, it's easy because you pay £9,000 upfront. This is how much it's worth today. This is the present value, right? So we don't need to do any adjustments. However, with the first offer, with the interest-free credit, we do need to do this. So here, the payment plan will consist of 2 parts. First of all, £1,000, which is paid right now, and the present value of this particular part is £1,000. There is no discounting because it's in present terms already. Right? It's the present value of this payment. It's £1,000. You pay it straight away. This is how much it's worth now. We'll need to discount this, though. Need to discount because it happens in the future. We need to discount this part. This is what we will do here. So this is the first part, no discounting. Second part of annuity with the discounting. From lecture notes, we know that there are formulas for the annuity, both for future and present values. You don't need to memorize this, but please make sure that you are able to find them quickly so you know where everything is located, because in the exam you won't have much time. Discounting formula, you won't have much time to search for this. Let me just go back. This is towards the end of the lecture. Here, present and future value of annuities. These are the formulas which you will need to use. You can also find relevant factors in the tables. Just make sure that you use the correct table. We need to calculate present value of a future annuity. In other words, we are going to use this formula. And this is where it is, right? We've applied this formula, so we've plugged in all of the numbers. A here is the value of the annuity itself, 3,000. I, interest rate, is 10%. And number of periods, N here, is 3 years. So just plug in all of the numbers into this formula. We can calculate the value in brackets ourselves, or we can find it in the table. I'll show you in a minute how to do it in a table. If we calculate everything, we will find that the value in brackets is equal to 2.4 something, multiplied by £3,000 of an annuity will give us a present value of this future loan payment. So we'll need to pay £7,460. This is the present value of our second element. How do we find this in a table? There is another table, present value of an ordinary annuity. So if I will go back to my whole tables, this is table 3 or 4. Let me just go back. Future value is table 3, but we are calculating the present value. So we will be using table 4. And similarly, we find a relevant column, 10%, and 3 years as a number of period. And at the intersection, we will find the relevant factor. And I've copied part of this table here so that you can see where we found it. So we take this number, and this should be equivalent to the number in brackets, right? So we just multiply the value of the annuity by this particular compounding factor. So what we've got? We've got our payment plan, which consists of two parts, £1,000 straight away and 7,400 in present terms for our credit. If we add them up together, we will get together. This is the combined value of our payments in today's terms, right? This is the value. Or alternatively, we can pay 9,000 upfront. So it works out that the first offer is actually cheaper. It's cheaper to us to pay a higher amount, but because of the high interest, because we can delay these payments, we can invest these £9,000 ourselves and we will generate higher returns. In today's terms, the first offer appears to be cheaper, which is not that obvious immediately, because you might think that, oh, £9,000, they give us a discount, I pay less. Here with the credit, I'll need to pay 10,000, which is not the case, because in present terms, because the interest is so significant, you could be earning this 10% on the money for 3 years, and you would be better off. So this is quite interesting situation, quite interesting scenario, and very relevant to your personal life. So whenever you buy a particular item, an expensive item, and you're offered interest-free credit, consider this option, because it might be quite useful. Moreover, during these 3 years, inflation actually erodes the value of your debt in real terms. Your £9,000 credit in today's terms will imply that you are able to purchase a certain amount of other goods for this amount. But in 3 years' time, it will be worth less in real terms because of inflation. Basically, inflation will eat away into the real value of your debt as well. So you will benefit from this angle too. Any questions based on this? No? Another interesting exercise 9, slightly different again. I'm trying to show you solutions to different types of exercises so that you're more or less familiar how to deal with different types of questions. Here, we have inherited an investment which will pay £100 each year for the next 20 years. So again, it's an annuity. Annuity is £100. The term of the annuity is 20 years. So annuity is £100. This is the cash flow, and is 20 years. Next, current interest rate is 15%, quite significant. You've been approached by a potential buyer who offers you £1,000 for this asset, but you laugh at these offers and walk away, because apparently you will receive £100 for 20 years. So just let's see, £100 for 20 years, which is £2,000. So this is what you expect to receive, but you've been only offered half of this. So you decided that it's a ridiculous offer, you immediately rejected this and walked away. Was it a wise decision or not? Interesting, right? You don't know immediately, because it appears that you've been offered just half of what you will receive. However, the very high interest rate here can give you a hint that it's not as straightforward as it might appear. We need to do the calculations, because if you're offered this money straight away upfront and invest them, this £1,000 at 15%, you might actually end up with a significantly higher capital during this period after 20 years, rather than getting this particular annuity. So let's have a look. In order to see whether you are better off selling this asset or keeping it, we'll need to calculate the present value of this annuity. In other words, how this future stream of cash flows is worth in today's terms. To do this, we use the formula for present value of annuities, again from our slide. So this is the slide which we've used. There are just two formulas for present and future value. We apply this formula as before. I've copied it here. Just plug in all of the numbers. The value of the annuity is £100. The value of interest is 15%, and our return is 20 years. We apply everything, right? So just written in a slightly different form, because it's difficult to type the equations in this particular software, but it's the same thing. And as a result, you will get that the actual value of this annuity in present terms is just £625. This is how much it is worth. In other words, if you invest £600 today, you will receive this future stream of income. Yeah, it's equivalent to 625 pounds. This is how much it's worth. But you've been offered £1,000 for it. You've been offered significantly more than it's actually worth. And you've rejected this offer, which means that you've just missed a good deal. You should have accepted this offer. In spite of the fact that it appears that you're only getting half of the payment because interest rate is so high, in today's terms, you are better off receiving the payment up front and investing it at 15% return elsewhere, savings account or something like this. You will get more at the end. You will be better off. Okay? Any questions? All other exercises, here I've provided detailed solutions. That's why I was surprised that your answers were only like one line long, because you can see here that my solutions are quite long. I took a lot of time preparing them, but you can refer to these solutions. They're available on Moodle just to work through all other exercises. Attempt them. We've covered majority of types of questions which you will get, but make sure that you practice with the rest of the calculations. Accountancy students tend to be quite capable and intelligent. Accountancy students usually have quite high intellectual abilities, and you should be able to cope with this. You are usually quite good with numbers, and generally you shouldn't face significant difficulties. This is not an easy topic. There are different formulas. The most important task is to understand which formula to apply and plug in the numbers correctly, and that's it. And tables can help you with this. Okay, let's proceed to multiple choice questions then. First exercise, multiple choice exercise. Which of the following statements is true? Statement 1, future value of a lump sum and future value of an annuity will both increase as you increase the interest rate. This is correct because you compound certain capital at the higher interest rate. Apparently your ending balance is going to be higher. So statement 1 is correct. Regardless of annuity or a lump sum, regardless of whether you invest a certain amount each year or you invest initial amount in 1 year and don't continue saving or investing later. Regardless of how you invest and save, the higher the interest, the higher your return will be. Your accumulated capital will be higher. So statement 1 is correct. As you increase the length of time from now until the time of receipt of a lump sum, the present value of the lump sum increases. No, the present value actually drops with time. The further in the future our payment is, the more we discount it, the higher the discount factor will be. The more the number of years, the more we will have to reduce the future value. If cash flows are appearing in the more distant future, they are less valuable for us because of time value of money. So statement 2 is incorrect. Present value of a lump sum to be received at some point in the future decreases as you increase interest rate. This is correct. The first part is correct. Present value will decrease with the high interest rate. We discount it more, so the present value will be lower. First part is correct, but the present value of an annuity increases as you increase interest rate. And this is incorrect because regardless of whether we are talking about annuity in the future or a lump sum, in any case, the higher the interest rate, the more we discount it. The present value will be discounted by more. So present value will drop. Present value drops with interest rate, both for lump sum and an annuity. So that is why the second part of the statement is incorrect. And that is why the only correct answer is A here. Statement 1 only is correct. Correct answer is A. Next. Which of the following best describes the structure of an annuity? It's a series of equal payments to be received at equal intervals during a period of time. Equal cash flows for a set period of time. The difference between annuities and perpetuities, annuity and perpetuity, is that for annuity we have fixed cash flow and fixed cash flow for perpetuities as well, received at regular intervals. In both cases, regular intervals, for example, every year or every quarter or every month, regular intervals here too. So these are the same for both types of annuities and perpetuities. The only difference here is that annuity will be paid or invested for fixed time, fixed period of time, while perpetuity is indefinitely, forever, basically, at least in theory, right? So this is the difference. Fixed time versus forever. So the correct definition here will be C. Annuity is a series of equal payments at equal intervals during a certain period of time. Next, question 3. Which of the following cannot be calculated at the end of its life? The future value of a perpetuity. This is cannot be calculated because this is a series of payments which continue indefinitely. It will never end. That is why theoretically it will keep accumulating. If we receive payments forever, our capital will keep growing. We cannot calculate the value in indefinite number of years. This is cannot be calculated because it continues forever. Okay? Yeah? The rest can be calculated. Interest paid earned on only the original principal borrowed or lent is often referred as a simple interest. The correct answer is D. So again, the difference between simple interest versus compound interest is that simple interest is only earned on original sum only, on original capital only, while compound interest is an interest on interest too. So this is earned on original capital, original balance, and accumulated interest as well. The interest earned in previous periods. This is the difference between simple and compound interest. So if we only earn it or pay it on the original borrowed amount, this is simple interest. Next, question 5. The concept of compound interest is what we've just covered, refers to the process of earning interest on the original amount plus interest on interest. So the correct answer is D. Again, it's based on the definition of simple and compound interest. Compound interest is an amazing thing to have when you invest, because initially your capital grows very, very slowly, but it will become exponential. Growth will become exponential with time. So if this is time, and this is your capital, due to compound interest, the longer time period you remain invested, the earlier you start investing, the higher your capital will be at the end of the investing period. So if you start early, even if you start at small sums, it will grow at exponential rate due to compound interest. Next, the value of money. I've covered this in the lecture. I quite like this lecture, so if you haven't seen it yet, please make sure that you watch it, The Power of Compound Interest. The value of money to be received in the future is lower than the value of the same amount of money in hand today. Again, this is what is reflected in the idea of time value of money. So present value is always less than the future value. We need to discount any future payments to bring it to today's terms. We need to reduce it to take into account the interest which could be earned, inflation, risk, and so on. It's always lower. Question 7. Interest paid on both the original principal borrowed and previous interest allowed is referred as compound interest. Again, this was a question which we've covered already. Paid on both original and interest, compound interest. All other options are just shown here just to distract you, like double interest, present value, discount rate, etc. Normal interest is a compound interest. Money times has value because there are possible options here, so let's consider each in turn. Individuals prefer future consumption to present consumption. No, we actually don't like delaying consumption. We don't like to make sacrifices. In reality, we strive for instant gratification. And there were quite a lot of psychological experiments when a child is offered a sweet now or 2 sweets in 5 minutes. And frequently they cannot wait. They cannot really force themselves to wait. They prefer instant gratification. And this is the case with many people. We frequently overpay because we prefer to purchase something on credit, even if credit is very expensive. We want things now. We don't want to keep saving for 5 years to be able to buy a car. We want it now. We splash out on credit cards. Many people go into significant debt issues because they cannot control their spending. They want to spend now rather than in the future. We value present consumption more than future consumption. We want everything now. Money today is worth more than money tomorrow in terms of higher purchasing power due to inflation. This is correct because inflation erodes the purchasing power of money. If you have money now, you can purchase more than in the future because prices of everything will grow. And if you keep a fixed capital now, fixed amount of money, like £1,000 or even £1,000,000, you will be able to purchase less in the future because prices will increase by then due to inflation. So current capital is more valuable. There is a possibility of earning return on money invested today. Of course, if you have money now rather than in the future, you will be able to invest them and earn interest, and in certain period of time, you will have a higher capital. So you would rather have them now rather than in the future. So B and C are correct. That is why the correct answer will be D here. B and C are correct options. The basic rule of time value of money is Investments will always be worth more tomorrow than they are today. No, because investments are not guaranteed. We hope that if we invest certain capital, we will be able to earn and our capital will grow. But in fact, every investment is associated with risk. It carries risks, especially if you invest in the stock market. There is always a possibility that this investment project is going to be loss-making. You will lose your capital. You can get back less than you invest. You should always be aware of this. Don't assume that it's guaranteed. The returns are never guaranteed, especially in a stock market. So A is incorrect. Not always more. Not always. We hope for this, but this is definitely not the case. It's always wiser to save £1 for tomorrow than to spend it today. Again, not always. You might be wise to save something for the future. You need to make retirement plans now because no one will care for you. Don't even hope that the government will pay you sufficient income to last in retirement. This is not enough to live on. The current pension is about £700 per month. Just think about this. Would you be able to live for £700, especially if you are old, if you need health care, and this might be costly, if you need carers, etc. Would this be enough for you? Would you have a sufficient lifestyle? Definitely not. And if you don't save enough money for your retirement yourself, you are going to basically to dive in poverty. Right? So it's wise to save some amount for the future, but not necessarily, it's not always correct for every single individual. It's not always wise, right? So there are different situations. I wouldn't say that this is always the case, especially in terms of inflation. If we live in a highly inflationary economy, if you save, your money will lose your value. So basically, there is no point. If inflation rate is greater than the return on your investment, it's wiser to spend now to purchase real goods rather than save it and lose the value of capital. A pound in hand today is worth more than a pound promised at some time in the future. Yes, this is correct because there is always a risk that it will not be paid. If it's promised, it doesn't mean that you will receive this money. So it's better to receive now. There is less uncertainty, so it's more beneficial. All of the above statements are correct? No, because A and B are not correct. So C is the correct option here. So these are our multiple choice questions. Are you okay with them? Let's talk about the test. This week you will have your test starting on Friday. The test will cover 2 topics. Let me just go back to Moodle to show you. So this forthcoming test will cover week 8, Introduction to Finance, Financial Environment, Firm's Financial Objectives, Agency Problems, things like that, which we've covered in the previous seminar, plus this particular topic, Time Value of Money, Compounding and Discounting. Right? This is what will be included in this test, and the next test will cover the remaining 2 topics. In this forthcoming assessment, you will get both multiple choice questions like this, which are simple, but don't hope that it will be all of it. You will need to do calculations. Even if you're offered certain options, you will still need to do calculations. So you need to be comfortable with compounding, discounting, calculating present and future values, including annuities and perpetuities. You don't need to memorize formulas, but you need to know which formula to use and keep your present value tables handy as well, because it might be quicker than trying to do calculations. And there is less probability that you will make an error when calculating something. Okay? Any questions? I will send you a reminder about the test on Thursday, the link and the password. You will get everything, but it will be in the same format as before. You should be familiar with it by now. That's it for today then. If there are no questions, thank you very much for coming.